Okay, so in the last slide, last session we have discussed regarding the origin of the four rectus muscle, and then we discussed regarding the what is the equator of the eyeball, what is the exact point of the insertion of all these four rectus muscle. Okay, now something we want to add, that is the what is the distance, exact distance from the sclerocorneal junction. What is the exact distance of the insertion of all these four rectus muscle which measures from the sclerocorneal junction? That point you note down. Okay, so all the four rectus muscle, namely you can note it: superior rectus, medial rectus, inferior rectus and lateral rectus muscle, inserted at the distance of 5 mm, 6 mm, 7 mm and 8 mm respectively from the sclerocorneal junction onto the scleral tissue. Okay, what you understand? All the four rectus muscle that insert onto the scleral tissue respectively at the distance of 5 mm, 6 mm, 7 mm and 8 mm from the sclerocorneal junction. Okay, so that's all about the insertion of the four rectus muscle. Okay, now we discuss the remaining two muscle, that is the two oblique muscle. Okay, so these are the two oblique muscles, superior and inferior oblique muscle. Okay, superior and inferior oblique muscle. First we try to locate in this diagram. This is the superior oblique muscle and this is the inferior oblique muscle. As we can see in the diagram, the name itself suggests they are oblique in nature. That means their course is oblique. Okay, here we can see it goes straight, then it becomes oblique. Same way this inferior oblique muscle, okay, it curves around the eyeball. Okay, again in oblique direction. While in case of the rectus, they are straight. Okay, so they are called as recti muscle. While oblique muscle, they have got oblique course. Now what is the origin? For that we take this diagram. Okay, so this is the key diagram to describe the origin of all the extraocular muscle. This is the laser wing of sphenoid. This is the greater wing of sphenoid. This is the superior orbital fissure, from where various vessels and nerve related to the orbit passes. This is our common tendinous ring of Zinn. Okay, so what is our point? Origin of the two oblique muscle. Okay, so first one is the superior oblique muscle. Okay, so we locate it over here, superior oblique. So what is the origin of superior oblique? The origin is outside the common tendinous ring of the Zinn. Outside means medial to the common tendinous ring of Zinn, from the laser wing of the sphenoid. Okay, so this is the point of the origin of superior oblique muscle. Once it originates from the laser wing of the sphenoid, it passes through the trochlear pulley. Okay, this green shade is suggesting the trochlear pulley. It is nothing but it is the modification of the periorbital fascia. Location of the trochlear pulley is on the anteromedial aspect of the roof of the orbit. Okay, so it winds around the trochlear pulley. Again the same structure over here, we can see it winds around the trochlear pulley. Okay, so initial course of the superior oblique muscle is immediately superior to the medial rectus muscle. Okay, it goes straight, then it hook around the trochlear pulley or trochlea, whatever you term, then it is directed backward and laterally, and ultimately it insert over the scleral tissue by piercing the episcleral space on the, more specifically speaking, on the posterosuperior quadrant of the eyeball behind the equator. This line is very important. Both the oblique muscle insert behind the equator of the eyeball, while all the four rectus muscle insert in front of the equator of the eyeball. Okay, so what is the insertion of the superior oblique? On the posterosuperior quadrant of the eyeball behind the equator. Okay, now we discuss about the inferior oblique muscle. As we can see, it comes from the underneath surface of the eyeball. Okay, for that we take some idea regarding the floor of the orbit. Okay, we see this diagram. Okay, again we discuss. This is the floor of the orbit. This is the roof, medial wall and lateral wall. Okay, so which are the structure forming the floor of the orbit? Again we repeat, lateral to medially. Following are the structure: orbital surface of the zygomatic bone, orbital surface of the maxilla mainly.